Good day, good people. Tech Tutoring again. I'm back here and I want to at least elucidate and clarify and actually take you through implicit differentiation. Because what I've seen is that if ever you are doing calculus, if ever you're doing engineering mathematics, you are always going to be doing anything that you have done from your first year or your foundation. You're going to still apply differential calculus. You're going to still apply integral calculus, and all of those things. You need to always remember them, right? So now we're going to be doing implicit, right? We're going to be doing implicit differentiation. Implicit differentiation, the day that I started doing implicit differentiation is the day that I've started knowing very well that sometimes we can get to neglect something for too long, and ultimately you can see that that which you used to neglect, it can be useful and it can be respected one day. Because now in this implicit differentiation, we find that we used to always derive with respect to x, always derive respecting one variable. But then now in implicit differentiation, we derive and respecting both variables or all variables, because if ever we now get an equation that is composed of x, y, z, and maybe w, we need to derive respecting everything or every variable that is there. That means there is no variable that is going to act as a constant, right? There is no variable that is going to act as a constant because everything is going to be derived. Now, say what? Say derive this, right? In grade 12, we used to use this sign. Say derive this. Find dy over dx of this kind of an equation. So that means here we'll say 2x plus 2y dy over dx, right? 0. You know we don't derive the constant, but then every variable needs to be derived here, right? So now there is this now that is here. So this is here because we are at least maximizing or respecting x more, right? So it's 2x plus 2y dx over dy over dx. Now it's 2y over, it's 2y, it's now 2y dx over dy over dx is equals to negative 2x, right? Then from there we have to divide both sides by 1 over 2y. We have to multiply by 1 over 2y, then it will multiply by 1 over 2y. Then we will have dy over dx. This is equals to negative 2x over 2y. This is going to be negative x over y. So this is your differentiation. That is complete now, right? So this is how you need to derive implicit differentiation. Say what? Say you have something like 2y squared plus 3x squared is equals to 4, right? So we need to derive this, right? So it's going to be 4y dy over dx plus 9x is equals to 0 because we don't derive the constant. Then from there, dy over dx is equals to negative 9x. Then from there, divide by 4y, then this will be dy over dx is equals to negative 9 over 4xy. So this is actually the final answer. Right. Now, this is how we should find the implicity, and this is how easy implicity is. Now, say what? Cos x and y plus, let's say, sine of x. Then they say derive this. First thing first, when you come across this kind of equation, you just need to know that the derivative of cos is negative sine. Then write it down. Negative sine x, y. The derivative of cos xy is negative sine xy. But then remember that you need to say the derivative of cos, then write it down and multiply it by the derivative of what is inside. Multiply it by the derivative of what is inside. Right? So now what is it that you're going to do? You're going to use the product rule. You're going to use the product rule to derive what is inside, which is x and y. So that means we need to find the derivative of x, which is going to be y, then plus the derivative of x. We're gonna have y 1, then multiply by the original y, plus the derivative of y. Derivative of y to be just dy over dx because it's 1, right? Then multiply by x, right? Plus, then this one will be just cos x, right? Let's say the equation said is equals to 1, then that means it will be equals to 0 as deriving this. Now we're gonna have to say negative sine x and y plus dy over dx multiplied by x is equals to negative cos x, right? So then from there, we need to say y plus dy over dx, x is equals to negative cos x divided by sine x, y, right? Then dy over dx, x is equals to negative cos x divided by x and y. Then you divide both sides by x, then you will get dy over dx is equals to negative cos x divided by sine x and y minus y. So this can be just 1 over x. This is equals to, so that means dy over dx is equals to 1 over x into negative cos x divided by sine x, y minus y. So I just did this example because you can just choose any example and then you perform and then you just solve, right? Don't forget to subscribe and comment anything that you might need to leave down on the GJ Tech Tutoring channel, and then that will be it. Enjoy the rest of your day and practice, and good luck on your exam preparation, and nail it and find it easy.